Welcome, everyone. We will begin the webinar on DeVilbiss Spraymaster Spray Gun 101. I'm Melissa Jolls with RDA Impact. Kevin Creegan, National Accounts Manager, and Jeff Bell, Account Manager, National Accounts for Saint-Gobain Abrasives, are your presenters today. The presentation will take approximately 40 to 45 minutes, and if you have questions during the webinar, you can type those in the chat box at the bottom right of your screen, and we will answer those during the presentation. Now, I'll turn it over to Kevin.
Thank you, Melissa. I appreciate the introduction. Welcome, everyone. Thanks for taking time out of your busy days to attend our webinar this afternoon or this morning if you're out on the West Coast. Today, we're going to cover DeVilbiss Spraymaster Spray Gun 101. Basically, we're going to handle the introductions, which has already taken place. Jeff will be covering spray gun basics. We'll talk a little bit about airflow and certainly discuss fluid flow, gun setups, various gun setups, and basically if you have any questions whatsoever on operation and proper feeding and care for a DeVilbiss spray gun, Jeff is your man. So without any further ado or delay, let me turn things over to our Master of Ceremonies and presenter, Mr. Jeff Bell. Jeff?
Hey, thanks, Kevin. And again, thanks everyone for joining. We appreciate you taking your time to come visit our presentation today. As Kevin mentioned, we're going to go through this agenda, talk about the spray gun basics and how a spray gun works. So a spray gun in general uses compressed air to atomize sprayable material and to apply it to a surface. The air and the material are mixed at the air cap to produce a controlled spray pattern. Most of the guns that we use in auto refinish industry, 99% of them are what we call an external mix spray gun, meaning that the air and the fluid are mixed outside the gun in front of the air cap. There are some guns that are called internal mix, and that happens inside the gun, but pretty much everything we use in auto refinish is going to be external mix. Okay? The spray gun body, it serves two purposes. One is to hold all the parts together that you need for the gun to function, and the other is it gives you something to hold on to. You know, we want it to be balanced and comfortable and make sure it fits your hand properly. In this particular slide here on airflow, you'll see the areas in blue. That's where the air travels through the spray gun. So you have your air inlet at the bottom of the gun, which would be at the little chrome part with the red ring around it. The air comes in the gun, up to the back of the gun, and the parts that work with the airflow are the items that are listed there. The air inlet, the air valve, the fan control, the baffle, the air cap. And again, mixes externally. The air inlet, which is at the bottom of the gun, provides the point for the gun to attach an air hose, or in a lot of cases, this is where the guys will put their air adjustment valve or their air adjusting valve with a gauge will attach there, and then the hose will attach to that. And it's an entry point for contaminants in an enclosed gun washer. So if you're using this gun in an enclosed gun washer, you want to make sure you're capping up that air inlet before it goes in there. There's no reason to have, contaminated fluid go through the air passage. As you can see from this slide, the area in red is the fluid flow, where the fluid goes through the gun. The area in blue is the airflow. When you're cleaning a fluid passage, again, you just want to clean the fluid passage. There's no sense in letting, the contaminated solvent. And when I mean contaminated, it's not that it's bad, but we just don't need to get that solvent that we're using to clean the fluid passage into the air passage. The air adjustment valve on a spray gun, they can be in a couple different places. Some of them are external, which would be mounted at the bottom of the gun, like I just spoke about on the previous slide. This one's actually built into the spray gun. Some guns have them built into. And it's not a diaphragm regulator. It's truly a cheater valve. It just restricts the flow through the gun body. It's a way for you to control the pressure of the gun that you're spraying at the gun instead of walking back and forth to the wall regulator every time to adjust your pressure. Okay, the air valve, which is the yellow part that's highlighted there in the back of the gun. It says air valve with the arrow pointed to it. Air valve does one thing. Turns the air on, shuts the air off. When you pull the trigger, it opens up a valve, lets the air flow through the gun. When you let go of the trigger, it shuts the air off. Now, depending on the gun, you can either have a cartridge style valve or a concentric style valve. The one in this picture we call a concentric style valve, and this is the one that's built around the fluid needle. Awada will use these. Anybody that remembers the old Binks guns that had the M1G or the M1G Clear, those had concentric style air valves. Your full-size DeVilbiss guns, SATA guns, the old NBCs, JGAs, those use what we call a cartridge style valve, and those will actually be a separate cartridge just below where that yellow air valve is now, and it's an extra machining process in the gun. One does not work any better than the other. It's just a different way to control the airflow. The fan control knob, which is the top knob on the back of the gun, controls the height of the spray pattern, the distribution of the air through the holes in the air horn on the air cap, and it balances the pattern. So what that valve does is when you turn that air adjustment knob on the back of the gun, it controls how much air comes through the horn holes on the air cap. When you turn that knob all the way in, there's no air coming through the horns, which means you get a round spray coming out of a spray gun. As you open that valve up and air starts coming through the horns, the stream of paint that's coming out the front of the gun, air hits it from the horns, hits the side of that round spray and puts it into a tall pattern, and that's where your oval fan pattern comes from. So it's just an air adjustment is all it is for how much air is coming out the front of the gun through the horn holes. Okay, fluid flow. Again, fluid flow is the red part, the part that's highlighted in red in the gun. Air comes in through the top of the gun where your disposable cup adapter would be or your cup would be mounted, comes through that small portion of the gun body, into the fluid tip, and out the front of the gun. The parts we're going to talk about for fluid flow is obviously the fluid inlet, the fluid needle, the fluid tip, and again, it mixes externally. The fluid adjustment knob, which is the yellow highlighted area on the back of the gun. It really does one thing, or two things. It controls how much pressure is on the needle to make it open and close. It also controls how far the needle will open. So there's a proper way to set that up, and we'll get into that farther into the presentation. But you want to make sure there's enough pressure on that spring on the back of that gun so when you let go of the trigger, the needle closes properly, but yet you don't want so much pressure on it that when you pull the trigger open that it's restricting fluid flow. You want to make sure the needle gets all the way out of the way of the fluid tip so you get proper flow coming out the tip of the gun. The other thing the needle does for the fluid needle itself, which is the yellow line running through the center of the gun, it is basically like the air valve for fluid. It turns the fluid on and off. It's a tapered seat needle on this particular gun, and it seats in the back of the needle or back of the fluid tip. When you pull the trigger, the needle comes out of the way of the tip, allowing fluid to come out the front of the gun. When you let go of the trigger, the needle seals off the back of the fluid tip, which stops the fluid flow. So it's just an on-off valve for the fluid. The fluid tip itself, this is going to be the yellow highlighted area in the cutaway of the gun here, controls how much fluid comes out the front of the gun. And this is also the seat that works with the needle to shut the fluid off where the needle seats into the back of that tip. The fluid flow is going to be controlled by the size of the tip that's in the front of that, the size of the hole that's in the front of that fluid tip. This chart here is just some guys go by thousandths of an inch, some guys go by millimeters. The industry standard anymore is millimeters. Most of the stuff we deal with in the automotive refinish side for color and clear is going to be 1.2 to 1.4, or it's going to be 47 thousandths to 55 thousandths. When you get into primers, sealers, epoxy primers, polyester primers, then you can see stuff that's 1.6, 1.8, even 2.5. Just a reference chart for a crossover for you. The air cap itself. So between the fluid tip and the air cap, that's where all the technology takes place in the manufacturing design of a spray gun. Those two pieces are what makes the magic happen. The fluid needle, the air valves, all that stuff just is on-off stuff. But the air cap and the fluid tip itself, that's where your atomization comes from. That's what shapes the paint into a pattern. That's what gives its paint its velocity when it comes out of the gun. This is one of my favorite pictures here, how a spray gun works. This is actually a picture of what we call CFD, or computational fluid dynamics. So this shows the velocity of the air as it comes through the gun. Obviously, the red has the most velocity, then the yellow, then the green. But at DeVilbiss, there's a guy that sits at a computer and does CFD design, and he can change holes and tips and holes and air caps and make the colors or the velocity of this animated drawing change as he designs guns. When he hits on something he thinks is going to perform, then they can go in and design that part and make a prototype and go test it instead of just trial and error making parts and pieces and see if they work or not. So it's a really efficient way to try to design guns to get, the best atomization for what we're looking for a specific product. Most of the guns that we deal with in the auto refinish side are what we consider gravity assist suction guns. Most people don't know that a gravity gun truly is still a suction gun. It creates suction at the air cap to pull material out. Okay? They are gravity because when you pull the trigger, any paint that's in the cup will fall out. A way to prove to yourself that these guns do create suction is if you're using a liner system or a cup, disposable cup type system, and you can turn that gun upside down with the cup on the bottom and pull the trigger, that gun will continue to spray. If the gun didn't create any suction, it would not continue to spray. So in a gravity gun, the cups are mounted above the gun. Paint flows down the fluid passage across the face of the fluid tip where it mixes externally with the atomization air. These are obviously great for the auto refinish industry because we do what we consider multiple color changes. We get some guys in body shops, 6, 7, 8 cars a day, so they're doing a lot of color changes, throughout the day versus in a plant setting where they may use a lot of pressure feed stuff and they're painting, UPS brown all day, then they would get into pressure pots and things like that. So our industry tends to use what we consider smaller amounts of paint for quick color change, hence the reason for disposable cups. Excuse me. With the DeVilbiss Techna Pro Light gun, it's a very versatile spray gun. There's 3 different air caps available, and those air caps are the difference in them is the amount of CFM that they use. The higher the CFM, the smaller the droplet size. And a real good way to look at this is if you just go down to the bottom row where it shows a 1.4 tip, and you look from left to right, you'll see that technically those droplet size gets bigger, going from an HV30 air cap to a TE20 air cap to a TE10 air cap. The difference in those air caps is an HV30 is a 17 CFM cap, a TE20 is a 12 CFM cap, and a TE10 is a 9 CFM cap. So the CFM is the cubic feet of air a minute that the spray gun uses. The less air that's coming through, the softer the spray. It doesn't have as much oomph or as much horsepower behind it to break the product up into smaller particles. So a 9 CFM cap is going to be a very soft spray, very controllable, bigger droplet size. By going up to a TE20 or an HV30, higher CFM cap, more cubic feet of air a minute coming out the front of the gun, it's going to take that same volume of paint that's coming through a 1.4 tip and break it up into a smaller particle. So with the DeVilbiss Pro Light guns, with 3 air caps and 3 fluid tips, there's 9 different setups there. And that's really good to know when working with waterborne products, because depending on where you're located, and on this call, we have people from all over the country, and you can have this one gun and make it work with waterborne paint wherever you're located. Those parts come in the kit to make that happen. So you don't have to go out and change a bunch of stuff or buy something different based on your geographic location. It's also nice from a distributor standpoint because there's one part number that the distributor needs to stock. There's not a part number for a 1.2 gun or a 1.3 gun or a 1.4 gun. There's just one part number that includes everything in the kit. This chart just breaks the CFM down a little bit more based on fluid flow. Most guys in our industry are going to spray somewhere in that 6 to 8 ounce a minute range. That's just a ballpark figure. Some guys like it to be a little slower. Some guys like it to be a little faster. But generally speaking, 6 to 8 ounce is a good target distance to look at. Once you know the ounces the guy likes to spray at per minute, then you can control that a little bit by droplet size. Well, I like those ounces, but it's a little too wet, then you can change air caps accordingly. And when you're selecting a spray gun, talk a little bit about HVLP. And what does HVLP mean? HVLP, the true definition, is 10 pounds or less at the air cap when you're spraying at a recommended inlet pressure. okay? And that pressure is measured at the center hole of the air cap, and that pressure has to be indicated somewhere on the spray gun. Doesn't matter, well, there's a slide that shows that. It can be on the air cap, it can be on the gun body, whatever, but somewhere on that gun has to say 23 pounds inlet, 29 pounds inlet, whatever the manufacturer recommends. So it has to be marked with that to get no more than 10 pounds pressure at the cap. If you're talking a compliance gun, or in some cases a high efficiency gun, just depends, what terminology you want to use. They all mean the same thing. There's paperwork included for those guns that tell you the difference in that, okay? This here shows the indication. The gun on the right is DeVilbiss. DeVilbiss marks it on the air cap, 26 pounds inlet. That's what's going to get you 10 at the cap. The other gun on the left is a SATA gun. There's just 29 pounds inlet to get you 10 on the cap. There's no right or wrong. It's just the way that it's done. So there should always be a pressure marked on a gun somewhere. Okay. Again, now after HVLP, which was out, late 80s through mid to late 90s, early mid late 90s, we came out with what we called compliant spray equipment. And the DeVilbiss GFG Plus gun, for you guys to remember that, was the first what we considered compliant gun. So there was a bunch of testing that was done that proved that we could get the same transfer efficiency with a compliant gun that we could get with an HVLP. So we took all that data, we went to the SCAQMD, which is the South Coast Air Quality Management District, submitted all our findings, and said, what's the difference on the cap pressure as long as my transfer efficiency is the same as what you're deeming your HVLP? Now remember, HVLP is no more than 10 pounds pressure at the cap. So that's all the pressure you have at the cap to break up a clear coat or anything of any type of substance is 10 pounds. So long story short, SCAQMD bought off on it. So as long as your transfer efficiency is equal to or greater than HVLP, and you can prove that to us, we'll allow you to do that. So we have to provide a compliance letter stating those facts. And in most cases, your air cap pressure is about 5 pounds less than your inlet pressure. So if you're spraying at 22 pounds, now have about 17 pounds pressure at the cap. 7 pounds more than you'd have with an HVLP gun. Easier to break up clear coats, easier to get, finer atomization. And then after that, other gun manufacturers followed in line with their RP guns or whatever they had as well. So there's a whole bunch of testing that has to go on to be able to prove that for the compliance. Here's a copy of the letter that comes with every DeVilbiss gun that meets high efficiency standards. There's also local ordinances and stuff that follow along. In most cases, if the SCAQMD buys off on it, then the other ones will follow suit. But there will be a letter included, and if there's not, or for some reason it's been misplaced, all this stuff is available on the DeVilbiss website, because it falls under the 6H rule where you have to show your compliance letters and all that stuff. So if you ever have any issues or don't have the letter anymore and you're being asked by someone that's, checking on your 6H status, you can go to the DeVilbiss website and pull up any of these approval certificates. Okay, a little bit about gun setup. This shows a DeVilbiss Cam Air 5-stage unit, proper setup, air hose coming off through a 3/8 hose attached to the spray gun, and then at the base of the gun there'd be a quick disconnect with an air adjusting valve. Okay, that would be your optimum setup if we were going to go in and set up something in a shop. What we don't want to see is sources of pressure loss. A spray gun will consistently use more airflow than any tool in the shop. And anybody that's ever painted a car will know there's nothing worse than trying to paint a car and not having enough air supply. The gun starts to drop off in pressure. As it starts to drop off in pressure, the paint doesn't get atomized properly. You get orange peely or texture finishes. It's just not a good way to go. So anytime you can eliminate a source for pressure loss, your chances of being successful in refinishing her car are greatly increased. So we don't want to see couplers or QDs right off of the air control unit in the gun. There's no need to have one there. We don't want to run ball filters that we're showing down there at the bottom. The ball filter is a great tool to use to diagnose a problem, but it should not be put on a gun and left. If you're running a good 5-stage unit off the wall, there's no reason to have that ball filter at the gun. If you need the ball filter at the gun, you got other issues downstream. So you want to run as few connections as possible. One of the questions that's brought up is, how long should my air hose be? The right answer, it should be as short as possible for you to comfortably paint a car and get around it in the booth that you have for your application. If you're someplace and you're painting parts all day and you're not moving very far, that air hose doesn't need to be very long. Most typically in most spray booths, it's going to be a 35-foot hose. That allows you to comfortably get both directions around the car if you're painting overalls. You know, in some cases, when you go into semi booths or tractor trailer rigs, and you're going to run 50-foot hoses because you're painting much bigger type equipment. One of the things that, DeVilbiss has worked really hard on is trying to standardize gun setups by improving the work quality and productivity while controlling material usage. Involves developing procedures that produce high quality work consistently and efficiently. So in short, if you set your gun up the same way, time after time, every time, when you have a problem, it's easy to go back and diagnose that problem. Now, when I say set the gun up, we're talking about the proper fluid tip, the right air adjustment for the fan control, the right fluid adjustment, the air pressure you're spraying at, all this stuff you should be documenting, or get your painters to document. That way, when there's a problem and they call you and say, hey, I got a lot of orange peel, what happened? And you start asking questions, you have something to help them diagnose the problem with. One of the most common questions you're going to ask, what pressure did you spray at? I don't know. What fluid tip's in the gun? I don't know. It makes it really hard to go back and fix a problem when you don't know what they did to start with. So if you start out being consistent in what you do when setting up a spray gun, and you do that the same way time after time, now when you have a problem, it's much easier to go back and diagnose that problem. And we have a chart that shows that as well. So all the work that we do with the paint companies, all the setups, everything that we put out on our website, and just for you, there's also a DeVilbiss spray gun app that's available to everybody. It's either on the Google Play Store for the Android or the App Store for Apple Store. And it's just an orange box with a pro light in the middle, and that gives you very basic information because that's what apps are intended for. It will give you gun setup, it will give you parts breakdown, there's a spray gun comparison chart, and there's also a little tab on basics of pressure feed setup. So that's available to end users, distributors, doesn't matter. It's free to everyone out there. It's really a nice tool. More detailed information is going to be available on the DeVilbiss website, which you can see there on the slide. But all the information and all the recommendations that we put out there, that's all out there by working with the paint companies. We just don't sit down in a room and say, well, we're going to spray this paint. We're going to say it needs a 1.4. This paint needs a 1.3. We go to the paint company training centers. We work with their application labs. Now, when we go in there and tell them what we're doing, they have a pretty good idea of a starting point where we're going to start because the paint companies know their product better than we do. And then we spray the product, and then they buy off on it before we ever publish anything. So any setups that you see DeVilbiss has published is going to come with from the paint company. And in most cases, they are going to give you a range. They're not going to say 1.3, that's it. They're going to say 1.2 to 1.4. And that's because of different geographic locations. Every painter sprays a different way. Some guys are closer, some guys are farther away, some guys move their arm faster, some guys move their arm slower. That's the funny part about our industry is there's really no standard. There's just a guide to get you close, and then you fine tune based on your own preferences. Okay, spray gun adjustments. Once you've looked up on your DeVilbiss app and you have the right fluid tip in the gun for the product you're spraying, there's really 3 adjustments on that gun. You have a pattern control knob that controls the height of the spray pattern or balances the spray pattern, whichever one you want to look at it. You have the fluid control knob that controls the amount of fluid that comes out the front of the spray gun. And then you have an air adjustment valve that controls the amount of air entering the spray gun, which is at the base of the gun. The initial setup on a spray gun. You buy a brand new gun, you've never sprayed anything through it. Obviously, the first thing I do is spray solvent through it and clean it, make sure there's no oils or contamination from machining or manufacturing. Once you do that, the pattern adjustment knob, so the top knob on the back of the gun should be adjusted all the way out, counterclockwise, as far as it will go. At this point, it's going to give you the tallest pattern possible. Now the fluid control knob, so the bottom knob on the back of the gun. Adjust the fluid control knob out until the full trigger can be easily achieved. So you'll continue to pull the trigger on the gun as you back that fluid control knob out. Once you feel you have full trigger, because the trigger will actually hit against the gun body. If you continue to back that knob out, there's a spring behind it that holds the needle. The knob will just come off the gun. So you don't want to do that. You want to adjust the knob back in till you feel it just start to push against the trigger. At that point, you have full trigger. That does two things for you. That gets the fluid needle out of the way of the fluid tip, so it's not restricting any fluid flow. It also gives you maximum spring tension on the fluid needle spring, so when you let go of the trigger, the needle's going to close properly, and you don't get any dripping or anything out the front of the gun. Some guys will say that's too much fluid, and they want to turn that fluid control knob in 2 or 3 turns. That restricts the fluid flow out of the tip, but it doesn't let the fluid flow out of the way of the tip the way it needs to. If you're spraying with a 1-3 tip and you think that's too much fluid, you put a 1-2 tip in the gun. You drop down a tip size. Same way, if you've got a 1-2 tip in the gun and you got that fluid knob adjusted the way we just said, and you're getting full trigger, by opening that knob up more is not going to get you any more fluid. The needle is already all the way out of the tip. So by getting more fluid, you got to take that 1.2 tip out and go to 1.3 fluid tip. But you should set the gun up the same way every time, time after time. Now, if the guy's going to be dusting in a door jamb or a hinge pillar or something, he's not going to spray it full trigger. He's just going to pull the trigger, quarter, half trigger, whatever, to dust that in, right? We get that, but we're talking about painting full panels or front ends or whatever. You always want to get full trigger. And again, if it's too much fluid, you just go to a smaller fluid tip. It's that simple. Digital gauge at the bottom of the gun. Okay, this is going to determine the correct inlet pressure for atomization. It also controls color match. Waterborne orientation coats are often sprayed 12 to 14 psi, which can easily be measured with a digital gauge. Real quick, I'll mention the difference between digital gauges or dial type gauges. Dial type gauges have a clock spring inside, so they're controlled by air pressure. By ASME standard, which is the Association of Mechanical Engineers, a dial type gauge that has the clock spring inside, it's accurate out of the box, brand new. It's accurate plus or minus 5 pounds. So 10 years ago, 15 years ago, that wasn't a big deal. I was spraying, you're spraying acrylic enamel, you're spraying it at 35, 40 pounds, whatever. More of it's a by sound type spraying back in those days anyways. Right? Guns were different, and if you're in the range, it sprayed just fine. Your digital gauges, like the one in this picture, by ASME standards, are accurate plus or minus a half a pound. So when you start talking waterborne products and your control coat needs to be at 12 pounds, 14 pounds, whatever it is, if you're spraying with a dial gauge, and you already know, I just said it can be accurate plus or minus 5 pounds, you're at 12, are you at 7, are you at 17? You don't know. It says 12, but you really don't know where it is. The next part that throws a wrench into that whole thing is you take that gauge off to put it in the gun washer. I'm talking about the dial gauge, and you throw it on the workbench, and you miss the bench, and it bounces and it hits the floor, and you pick it back up. Well, now that spring is out of whack from where it was originally. The pressure may be closer. It may be off farther. We don't know. The nice thing about these digital gauges, if that happens, they have a reset on them where they can be recalibrated. You just push the button in until 3 lines hold up. Once the 3 lines show up, you let go of the trigger, let go of the button, and the gauge will read 0.0. You always recalibrate a gauge when it is not hooked to air. So you want to make sure it's disconnected from air, and it'll read 0.0. If it reads anything else, recalibrate it again, it'll be 0.0. So now with the digital gauge, if you're spraying at 14 pounds, you're either at 13.5 or 14.5, but you're a heck of a lot closer than you are with the other ones. Okay, a little bit about spray pattern and gun setup and how to adjust a gun. A split pattern, too much air pressure, right? That's what's causing it, too much pressure at the front of the gun. What I like about this picture is you can see the lightness of the material in the middle of the picture and how it looks heavy top and bottom. That's what we call a split pattern. If you look at the picture on the right of this slide, some people call it a dog bone pattern, a figure 8 pattern, hourglass pattern, all mean the same thing. Earlier when I spoke about the amount of air coming through the horns, that air coming through the horns is more than what the volume of paint can handle, so it starts to blow out the center of that pattern. That's what causes that. So anytime we adjust a spray gun, we perform a static and a dynamic spray pattern. And the static pattern is going to be the one on the left. It's just a quick burst. You want to look at your pattern. The dynamic pattern is going to be a pass. You start to spray and you make a pass on your masking paper, 6, 8, 10 inches, 2 foot, whatever you want to spray. And you're going to check the droplets at the edge of the pattern for evenness. So when I look at a spray pattern, I'm looking at the overall picture of the pattern to make sure it looks even from top to bottom, but that's really just a glance. My detailed looking at that is going to be just to the outside of the spray pattern, all the way around the whole pattern itself on the static pattern on the left, and I'm looking at the size of the droplets, and I want to make sure those droplets are very even from the bottom of that pattern all the way to the top of that pattern, even in the middle. If I was to look at this pattern right here that you're seeing that's split in the center, I'm going to have much smaller droplets in the center of that pattern than I'm going to have at the top and bottom. That's why it's blowing the center of the pattern out. So if the droplets are too small, adjust your air pressure until desired droplet is achieved, and then turn past until it's balanced. So the first thing I'm going to do is start to drop my air pressure and bring my air pressure back in. So you got 2 adjustments to do that, air pressure and fan control. It's just a matter of balancing those 2 out. Same way if I have a heavy center pattern, my air pressure is too low, and you can see it on this one where it looks like you have more material in the center and you have less material in the top and bottom. So when we look at the static and dynamic patterns on this one, we're going to increase our air pressure to get more pressure to the horns to balance that pattern out, or I can raise my inlet pressure. Once you've checked with your paint company recommendation, paint company charts, and you have the tip in that they're recommending and your fluid needle set properly, the spray gun is just a matter of balancing the inlet pressure with the fan control knob. It's basically a carburetor. Guys that are car guys, carburetors adjust air fuel mixture. You're adjusting air fluid mixture with paint. That's all you're doing. Once you have a balanced spray pattern, that pattern's going to look very even from top to bottom. And one thing that I do in a lot of shops, tap water. Tap water is very consistent in viscosity to base coat. And if you take tap water and put in a gun, you can mess with these adjustments and see exactly what they do. And if you hold the gun slightly up over your head and look through the fan pattern of tap water, like towards a light or a fluorescent light, you can see that pattern very, very well. You're backlighting the material coming out so you can see the droplet size. And tap water, obviously, it's not going to get in anybody's eyes. There's no issues with doing that. So it's very easy when you're doing spray gun training to do a lot of training with tap water and show the balance pattern, show the split pattern, show the heavy pattern, and that all works very well with, like I say, with tap water.
Jeff, I have a question.
Yeah. Sure.
The question is there any way to change the battery on the digital gauge? He has sold some from last year, and I guess they've gone dead in a matter of months.
Okay. So the quick answer to that is no, there is not technically. If you have one that's gone bad in a matter of months, get a hold of your local DeVilbiss rep, and that gauge will be replaced. Those gauges have a 1-year warranty from the purchase of a spray gun. So as long as it's within that year, there's no issues with that. They're not designed to be in gun washers and things like that, so make sure that's not happening. But we'll be more than happy to take care of the gauges. They can get dropped. They are a little sensitive. There was a change made to that gauge. I can tell you that about, it's probably been a year ago now or a little better, to make them more robust. They found that some of these soldering in the circuit boards were a little weak, so they updated that. So get a hold of your local DeVilbiss rep, and we have a slide at the end with all the contact information, and we'll be more than happy to replace those gauges for you.
Thank you.
Mm-hmm. So once you get your correct pattern set up, you're again perform your static and your dynamic spray pattern. Make sure it's even. Look at your droplet size, and you're good to go. I know it sounds like a lot of work to set up a gun, but it's really not. Guys that I'm sure a lot of you guys out here painted in the past, and you know how to do this. So once the gun's been correctly adjusted for air pressure, pattern size, fluid flow, record those settings. Write down your air pressure. Right? There's indicators on the back of the gun for the fan control and the fluid control. Look at where that indicator points and count the number of turns clockwise or in until it stops, and write it down. The same with your fluid control knob. Now, the fluid control knob is going to be pretty much set because we want to get full trigger, but especially your fan control knob, if I'm 2.5 turns out every time and I know that, then all I have to do is take this little chart, which, DeVilbiss has available. You can print off, you can put on someone's spray booth wall. Guys will take a piece of masking tape, and here's your sealer, your base, your coverage coat or your control coat, your clear coat, whatever product you're spraying. What gun am I spraying with? What fluid tips in the gun? What air cap? What was my inlet pressure? What was my turns on my pattern control or my fan control knob? And what's my turns on my fluid control knob? Now when a guy has a problem and the tech rep goes in and he says, yeah, my color was too dark, or my job was too orange peely, whatever. Okay, what'd you spray at? Well, I used my DeVilbiss Technigun with a TE20 with a 1.3, and I sprayed at 17 pounds, and he knows exactly what he did. Now we have a starting place to go help diagnose someone's issue. There's a lot of good painters out there. There's a lot of guys that do this when they set their guns up, and they know every time they set this gun up, and they're very consistent in what they do. Now when they have a problem, maybe it is a product problem. We're not all perfect. Every now and then there's a bad spray gun made. Every now and then a paint company has a problem with the product as well. It can happen. But if you're painting something consistently time after time, now you can start to decipher where those problems are, and they're easier to diagnose. Okay? A little bit about troubleshooting and what we run into. Okay? Most of the problems you run into with troubleshooting spray equipment is either fluid tip or air cap related. And out of those two things, I would say 70 or 80% of the problem is going to be air cap related. So what we recommend always when you're done, now this does not have to happen every time you paint a car, but I would say at the end of the day, soak the air cap in a good quality type thinner, acetone, cleaner, whatever it is that you're using to clean your guns with. You want to have a nice little brush for cleaning the air cap. If you look at the holes in these air caps, and I don't care what gun manufacturer it is, some of these holes are very, very small. And some of that it's related to the paint companies making products that are required to, look better, last longer. It's also requiring, some of the compliant type solvents that they have to use. And then it's the spray gun manufacturers coming up with ways to spray that product. So with some of these holes being so small in these air caps, I can't tell you how many times I've been into a shop and I'll tell the guy, you got a dirty air cap. Oh, no, I cleaned it. Well, just look those air caps over really well, because sometimes you'll get a little clear coat that'll build up in some of them holes, and they don't look like it because it's clear coat. But if you soak it in some good solvent, you blow it out with high pressure, there's gun cleaning kits available out there that have little wires made for cleaning those holes. Don't go to your oxygen acetylene torches and get the torch tip cleaners and clean your air caps. That's not what they're made for. But get the proper tool for cleaning it, and it'll make your guns last a lot longer, and you'll have less chance of problems on down the road. So problems with uneven patterns can easily be diagnosed by simply rotating the air cap. What they mean by that, if I spray a spray pattern, and let's look at the top pattern on the left, and I'm heavy top, skinny bottom. If I rotate my air cap 180 degrees and my pattern changes to look like the one on the left, my problem is with my air cap. There's no question that it's anything else but the air cap. I changed the air cap, the pattern changed, the problem's with the air cap. It could be dirty, it could be out of round, it could be somebody dropped it, whatever, but there's something wrong with the air cap. If I rotate that air cap 180 degrees and my pattern continues to look like the one on the left, it doesn't change, Now my problem is with my fluid tip. It's that simple, guys. It's one or the other. The pattern changes. What did you change? You change the air cap. The pattern doesn't change, and you change the air cap, the problem is with the fluid tip. And my guess is if it's with the fluid tip, they had it out sometime to clean it, they dropped it, and it's going to be flat-sided someplace. Very common. Same way if you look at the patterns on the bottom. If you have a crescent shape or a hook-type pattern, you rotate your air cap 180 degrees, pattern changes, it's the air cap. Those are the two things that control the pattern. Every now and then you run into something else oddball, but air cap and fluid tip is it. And like I say, the real easy diagnosis, you rotate the air cap. Okay, we talk about pattern adjustment knobs turn in too far, so you got a heavy center pattern. Material flow can exceed the capability of the air cap. That's not that common anymore, more so with pressure feed, but the atomization pressure can be too low. Your material could be too thick. You know, when you look at the bottom pattern where it's split, the fluid adjustment knob is set too far in, your atomization pressure is too high, or your fan control knob is out too far and you're splitting that pattern out. Again, when the air comes through them horn holes and it's too much pressure coming through the horn holes, hits the center of that pattern, it blows it into that split pattern just like we're looking at. Okay, anybody ever seen a gun that pulsates or spits? You get that pulsating, that spitting of a gun where air is getting in the fluid passage. Most of the time it's a loose or damaged fluid tip seat. So the guy's had the gun apart, he's cleaned it, he's put it back together, he has not tightened up the fluid tip tight enough. The fluid tips in spray guns are a metal to metal seat. The tips are made out of stainless steel, the gun bodies are made out of aluminum, so it's a stainless to aluminum seat that you got to create that seal between the two to tighten it up. It can be materials too low, right? The gun starts to run out of paint. There can be an obstruction. You could have a dry or loose needle packing. You could have a vent hole that's plugged in a cup. That doesn't happen that much anymore because of the disposable cup situation. Most of the time, it's a loose or damaged fluid tip. It's no different than if you've ever had the water lines apart in your house, you put a new faucet in or whatever the case is. The first time you turn that faucet back on, you get a bunch of pulsating and spitting. You have air mixed in with the fluid or the water in this case. Until all the air gets out of the system, then you get good fluid flow. Same way with a spray gun. Air is getting into that fluid passage that's causing that gun to pulsate and spit. You got to find that air leak wherever it is, was, whatever the case may be. Okay, any questions we can answer for you guys? That kind of covers everything about spray guns and setups, parts and pieces.
Well, there was one comment, and they were just asking if when they do get a hold of the rep in their area, if they could have access to those charts that you've been showing throughout the presentation.
Yeah, I don't see any reason why not.
Again, we'll follow up with everybody on the call with this contact information. And we want to thank everybody and be safe.
Really appreciate everyone taking their time to listen to our presentation today. Thank you very much.